address. So alloc is apparently not only allocating the object, it is allocating it and then handing back the address, something like 123, wherever it is in RAM, and so that value is what's getting stored on the left-hand side, which is that 64-bit chunk of memory designed to hold the address of an object. Hand over here, Peter.
So without calling init, is it actually an instantiated object, or is it just the memory has been allocated?
Good question. Just the latter. So when you call alloc, all you have done is allocated the object, and therefore returning its address. You have not initialized it, but in many cases, initializing it doesn't have an actual effect. It's rather a human convention, a programmer's convention, that we've adopted in the world of Objective-C, that even if your init method doesn't do anything, it should exist by convention. You should call it. So this line of code, out of context, is not complete. We have not initialized the object just yet. Now, because student, and in the previous slide foo, descend from presumably NSObject, the folks at Apple essentially gave us for free an implementation of init for any descendant class. So we could call init here. We could call init on a foo object and rest assured that it will actually work. It just so happens that the person who implemented the init method for NSObject just essentially returned immediately. They didn't actually do anything because you won't know what the descendant class is how it's supposed to be configured anyway. So in short, whenever allocating an object, you should always allocate it with alloc or some similar mechanism, as we'll see, convenience methods as they're called, and initialize it. But you sometimes have different ways of initializing objects. There are methods beyond just the one called init. There's longer names that we'll sometimes see, and we can create them ourselves. Yes?
Auto-release pool will release that memory at some point?
Good question. It's not so much that the auto-release pool will release that memory at some point, but we have created in main a pool of memory designed to be auto-released by the operating system later. So short answer, yes, but not quite with that language. This object will eventually be freed when the operating system realizes no one needs this object anymore. And that's the difference vis-a-vis 2 years ago. We, the programmers, would have had to keep track of when we're done using this student object and explicitly free it or deallocate it later. But we no longer have to do that. All right, just a couple other things to recap. So there's that student init method. And I keep calling these methods, but really in Objective-C, the lexicon is a little different. When you have open bracket student init close bracket, you're not exactly calling the init method. You're passing the init message to the student object. Now, at the end of the day, it's functionally the same thing. It's just sort of a different view of the world. But when you see messages being described, a message is the act of calling a method, if you come from the world of Java or C++ or other languages that have more conventional methods. How about these bottom two? Student age and student set age. What do you think the first one, student age, does? It's a valid expression. Yeah? It's a getter. So that presumably returns the value of an instance variable called age. All right, how about the one below it? So a setter. So in this case, it's presumably setting some instance variable to the value 20. All right, and it turns out, as you may recall, the instance variables underneath the hood might not even be called that exactly. That's an implementation detail for which there are conventions. But we'll see over time how we can choose those instance variables on our own. All right, a couple more complex topics, not that you have to be totally comfortable with just yet, but just be mindful of as we see them later tonight. So a category allows us to do what, if you recall? Yeah? It's like an extension to a class. What do you mean by that? Yeah, exactly. A category allows you to add more methods to an existing class. This is particularly helpful for large classes that might have, let's say, 100 different methods or 100 different selectors that you can pass to objects. And you just want to kind of categorize them. You want to have the messages related to this functionality, different messages related to this functionality. You can put them in distinct categories. You can put them in distinct files. Different people can work on different subsets of functionality for a class. So they're useful in that regard. Somewhat similar in spirit to JavaScript and the prototype property, whereby you can add functionality to existing objects via a somewhat similar mechanism. All right, and we will also see them in the context sort of a clever trick that folks have adopted. We'll also see them as a means of implementing effectively private members, private methods, or instance variables to a class that you don't want the rest of the world to know about by putting them in your .h file. But we'll see that by example. Yeah?
What's the design guideline? Do you put functionality in categories, or do you put them into their own classes?
Good question. So what guideline do we decide where to put our method declarations? For instance, why might we put Baz inside of a category as opposed to somewhere else? So a couple of reasons, just to recap. One might be if I am the guy implementing the bar category of methods, I just have chosen for development convenience to put them all in one file, therefore all in one category, so that I can kind of mesh nicely with colleagues who are implementing other categories of methods. So it's just programmatic convenience. But we'll also see instances where if you want to have instance methods associated with a class, but you want them effectively to be private, not broadcasted or advertised to the world, you don't want to put them, therefore, in your .h file, because then anyone poking around at your library would see them by nature of what a header file is meant to be. It's meant to be included by other people or imported by other people. So you can tuck them away and still document them and still teach the compiler that they exist, which is helpful for you using Xcode since it knows more about your code. But you're not advertising them to the rest of the world. It doesn't make them truly private, because you can still send any message to any object that you want, and just on a whim, hoping that it exists, and if it exists, it will be responded to. But it's a mechanism to approximate that idea of privacy. It's just not strictly enforced. So I would keep those two guidelines in mind. And lastly, protocols. This is a more complex manifestation of this than we'll see later today, but a protocol lets us do what in Objective-C? Yeah?
Define a set of methods that should be implemented by the class that implements the protocol.
Exactly. It allows us to define a set of methods that should be implemented by some class that adheres to that protocol. So if you're familiar with Java, it's effectively an interface, and other languages have the same conventions. It is a set of methods that you, a class, promise to implement if you declare yourself as adhering to that protocol. And there are ways of specifying that the methods are optional, but by default, they would typically be required. And the compiler will yell at you if you say, I'm implementing the NS copying protocol, but you, the programmer, forget to actually get around to implementing the required methods to make that possible. All right, so the biggest takeaways from this recap, I would say, are 1, what a pointer is, 2, what an object is, and I think those two would make me pretty happy moving forward. So just to recap, an object is an instantiation or an instance of a class. A pointer is? It's an address of some piece of data, and that will often be the address of some object. So if you're comfortable with those two definitions, I think we can get through this. All right, so iOS. So iOS adheres to a design paradigm, generally known as MVC, which stands for, as you might guess, Model View Controller. So we're not really going to spend any time on the M today, but we will spend time on the C and the V, the controller and the view. And you can think of the controller of a program that adheres to this MVC paradigm as really being the brains of your program. It's where you probably spend much of your time implementing your program's logic, responding to user interactions, displaying things on the screen. But with that last goal, displaying things on the screen, all you do is tell someone else to actually do the rendering of information on the screen. So if I'm a program, for instance, whose purpose in life is to display someone's account balance in their bank account, I, being the controller, would respond to the user's username and password. I might somehow check that their username and password are correct when they log into the bank's website. And then I, the controller, upon realizing, OK, this is user David, I'm going to go check his bank account. And I'm going to check that by asking someone called the model, but more on that in the future. Once I have that value, like $100, I'm then going to hand that value, 100.00, to something called a view to actually present that information to the user. So in other words, data is typically stored in the model. In this case, that's where my financial numbers might be stored. The controller is going to be the brains. All of the code that you write to sort of respond to ifs and elses and for loops and while loops will often be inside of your controller. And then when it comes time to display the results of all that number crunching to the user, you typically hand the data that you have gathered or computed off to something called the view. And the view takes it that last mile. It's sort of the HTML and the CSS of the world of the web. In the context of iOS, it's going to have to do with what the user sees on the glass screen. So this is a paradigm that you should keep in mind, because at many junctures, particularly with the iOS project, the staff's choice, you'll have to decide for yourself, where do I put this variable? Where do I store this data? Where do I actually display something on the screen? And the goal with